I made the last video way too long, but there's always a second try. This one. Alright. What astronomers do is they say, hey, you start with a big cloud of dust and gas, and then it gravitationally collapses upon itself, forming the star. Okay? There's only 3 problems with that. First problem, there is nothing pulling the material into the center. Where is this object? How exactly does a cloud collapse when there's nothing in the center? Where is this? Where is this little thing? How exactly do you make a cloud collapse when there's nothing causing the gravitation? Collapses gravitationally, so where is the gravitating object? What they do is say, oh no, you just have to trust us. What we call that in the real world is a miracle. Okay? Problem number 2. How exactly do you heat the material? How does it get hot? Okay? Gravity does not heat matter. Believe it or not, it doesn't heat matter. You don't have to take my word for it. Go to Home Depot and see if you can purchase a gravity torch or a gravity welder. Let's see what the people there that work there will have to say to you about that. Okay. Problem number 3. Gravity does not separate charge. In order to have a charge equalization event to birth a star, you have to separate charge. Okay? In order to do that, you have to have friction. 3 huge problems with astronomers' model of how stars are born. Now, I'm not just complaining about this. I actually have a solution. You have your big cloud of dust and gas, and you have charge buildup. Okay? And all these charges are rubbing against each other, causing friction. Eventually, they start collecting in the central regions. Okay? And all this material starts moving towards the center. And as it moves towards the center, it causes huge electrical current, which then further magnetizes the material, causing huge, powerful magnetic fields to further pinch the material, so it's a feedback loop. Being there's no gravity to pick which direction this goes in, it happens all over the place. This is similar to a cloud. You have your big cloud, you have your ground, and you have your negative charges and your positive charges, okay, which then equalize with lightning. I suggest you grab your thunder buddy. Anyways, positive, negative, charge equalization, boom. Charges equalize. Pretty bright event right there. But if you take this cloud, make it a light year in diameter, and make this charge incredible, like huge amounts of charge, and cause the friction to be on the stellar scale, yeah, you're going to have, instead of those lightning bolts, all that material, if there's a lightning bolt going through it, boom. It's going to ionize that entire freaking thing, and it's going to birth a star. And it was very unscientific of me, to assume that, but there it is. Now we can see these events. This is going to be a very poor drawing of the Cat's Eye Nebula, but I'll give it my best. And you have this. Cat's Eye Nebula. That's evidence for stellar birth. This is the interstellar placenta leaving the star after it was immediately born. And over time, that placenta will dissipate and it will leave a really hot white dwarf in the center. This thing will expand pretty rapidly into a blue giant. Now if you notice, that blue giant is where the astronomers started. Remember? They had the big cloud of gas and dust which collapses on itself. That's where they start. Their nebular collapsing dust cloud has always been the star. It's never been a diffuse thing of dust. Where they start, they always start with the star already formed. They never go through the previous processes. There are at least like 4 to 5 different events that need to happen before the star can reach the stage that astronomers are familiar and safe with. Hopefully people can understand this. If you have any questions or comments, please leave them below.